Every day, the world awakens with an ever greater thirst for energy. The emerging nations of India and China, with populations of more than 1 billion, are growing at 7 to 10% annually, adding exponentially to the global demand for energy. It's estimated the demand for electricity will reach 18.7 terawatts in 2010. By the year 2030, that number is likely to reach a staggering 30 terawatts. Today, 82% of our energy needs are met by fossil fuels, oil, natural gas, and coal, and nuclear energy. Fossil fuels and nuclear energy come with inherent security and environmental risks. Oil, coal, and natural gas are a finite resource as well, making our current energy mix inadequate in meeting our future energy demands. There is now a solution for meeting our future energy demands: solar energy. Every hour, the sun provides more energy to Earth than we consume globally in the course of an entire year. Right now, solar energy accounts for less than 0.1% of our entire global energy mix. There are 3 reasons solar energy has yet to make a larger impact on global energy supply: expense, efficiency, and scalability. The past 2 decades have produced 2 leading manufactured solar PV or photovoltaic systems: crystalline silicon and thin-film PV. Although silicon is in great abundance and extremely cheap, the purity required to make monocrystalline silicon PV efficient requires costly manufacturing procedures. This has prevented crystalline silicon PV from achieving terawatt implementation. The fastest growing PV technology is called thin-film PV. By creating extremely thin layers of material, thin-film PVs are able to lower their manufacturing costs dramatically over crystalline silicon PV. Unfortunately, thin-film achieves lower performance efficiencies over silicon PV because of material defects, preventing it from capturing as much energy. In addition, thin-film PV technologies rely on the use of rare elements in their manufacture, such as cadmium telluride and copper indium gallium diselenide. These rare earth elements will prevent thin film from ever achieving terawatt-scale power distribution due to their lack of abundance on Earth. There is another solar solution. QuantumSolarPower Corporation's NGD, or Next Generation Device.
One thing that I think is very promising about our technology is its ability to hit the major requirements for large-scale energy production.
The cost of electricity from a new coal power plant is about 10 cents per kilowatt hour. And to get below that level, we need 2 things. One is you need cheap modules. At the same time, you need high efficiencies, more than 20% power conversion efficiency. Quantum Solar's next generation device technology has the potential to reach costs on the order of 6 to 9 cents per kilowatt hour.
Some of those thin film solar technologies rely on material components that are not high in natural abundance on Earth. So they're inherently difficult to get a hold of, hard to mine, and expensive. And that places also some inherent limitations on the extent to which that technology can be implemented for worldwide production. So in other words, it can't, because it's on the order of about 1,000 times smaller in capacity compared to what you would need for large-scale energy production on Earth.
QuantumSolarPower's NGD technology is a patent-pending solution to our global energy needs. It will provide inexpensive, efficient solar power using abundant, non-toxic materials. The solar PV market is expected to grow by 58% to an $18.9 billion market in 2010. With the implementation of NGD technology, solar energy could easily reach a $500 billion market by 2030.
From September 2008, we've only been at it for a little over 18 months, and we've made some very significant headway in all of those directions, all of those benchmarks.
Quantum's next generation device will cause a paradigm shift in the way solar power technology is provided today. Our engineers set about to develop a completely new technology based on something that was completely different, that would give us all of the efficiency requirements that we need for large-scale deployment, but also to provide that high efficiency at a very low cost as well. And so what you end up with is a product then that is highly competitive to coal, which is really the holy grail of the industry. That's something that everybody is trying to achieve.
For the first time ever, Quantum's NGD technology will make solar a viable energy source by achieving the holy grail of renewable energy, the ability to compete with coal-powered electricity. Quantum's NGD technology, next-generation technology for this generation. Quantum Solar Power Corporation.